Hello out there. Great to see you. I'm Sonia and I love science. I just kind of wonder about everyday things and I let my curiosity lead me down a learning pathway. So, on behalf of CK-12, got my shirt on. Don't worry, I washed it. Let's do some science, ask some fun questions, and travel down a learning pathway together. Alone, but together. So, for those of you who have watched all my lessons, like my grandma, hi grandma, we are going to apply the principles we've been exploring in electricity and magnetism and combine them by learning about electromagnetism. New to the show? Don't worry about a thing. I'm going to review all the big ideas so you won't miss a beat. And you can always click on the links to the past videos in our CK-12 Live playlist if needed. Right below. Okay, so let's take a big idea from our study of electricity. Electric current is the movement of electric charges, okay? Then let's take a big idea from our study of magnetism. Moving charges create magnetic fields, okay? Let's put them together. Electromagnetism must be the magnetic fields produced by an electric current. Okay, let's compare. So a fridge magnet, in the fridge magnet we spoke about before, the source of the magnetic field were the electrons orbiting the atoms that make up the magnet, and they all lined up the same way. In an electromagnet, the source of the magnetic field are the charges flowing through a wire in a circuit. Now, this can be really useful because we can control the flow of charge in an electric circuit with a switch, right? We can turn it on or off, also giving us control of the magnetic field. In addition, there are ways we can manipulate the wire to increase the strength of the magnetic field. We can increase the amount of current running through the wire. We can coil the wire. The magnetic field around a coil wire is stronger than the magnetic field around a straight wire. We actually call a coil of wire with current flowing through it a solenoid. Isn't that the best word? Solenoid. Okay, try to say that 10 times fast. Let's do it. Ready? Solenoid, 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 solenoid. Hard, but we did it. Solenoids and other types of electromagnets are really useful to us. We use them all the time. Motors, generators, dishwashers, speakers, headphones, MRI machines. There are many more examples. Okay, so let's hop on CK-12 right now and explore electromagnetism. I'm sure we have some examples of cool electromagnets to explore. So let me share my screen. And we will go to CK-12's homepage at www.ck12.org. And let me hide my bookmark. There we go. Okay, so here is CK-12's homepage. No place like home. And I'm just gonna type in electromagnetism into the search bar. Okay, easy enough. And let's see what the first thing that pops up, I'm gonna click on it. Okay. How cute is this guy? He looks like my dog, Cody. I have a golden retriever. It looks just like that. What a clever dog. He wants to go inside to get out of the rain, so he's ringing a doorbell. Can your dog do that? I need to train my dog to do that. Does your home have a doorbell? Do you ever wonder how a doorbell works? The answer is electromagnetism. So here's our lesson on electromagnetism, and it's giving the example of a doorbell. And luckily, CK-12 has a simulation that shows us all the invisible things happening in the electromagnet, and it makes the invisible visible. So I'm going to click over here. In the top right, there's these like 9 squares. and it has related content. So this is just like CK-12 style, right? We always have in our science reads a cool picture, kind of an example of an everyday connection with some questions, right? And then related content for you to explore. So if I click on related content, there is the doorbell sim I was talking about. So let's discover more about how a doorbell works. All right, how does a doorbell work? Let's press play. All right, so this, you heard the sound of the doorbell. This is one of our sims that has sound, very fun. So when you pass an electric current through a coil of wire, you create an electromagnet. This is our big idea for today, okay? Pass electric current through a coil of wire, you create an electromagnet. Now, like I said, electricity is very dangerous, and kind of exploring electromagnets can be dangerous. So don't try it at home, and that's why we have this simulation for you, so we can explore electromagnetics safely using the simulation. Let's talk about what we're looking at here, okay? So relying on some of the things we learned about in our circuit diagrams, right here we have a symbol of an open switch, okay? So right now there is no current flowing because the switch is open, right? Then we have a bunch of coils, right? And this must be our solenoid. Now in this solenoid, they actually put a magnet in the middle of the coil of wire, and that just bumps up the magnetic field. So right there is our solenoid, okay? And then at the top here, we have long line, short line, long line, short line, long line, short line. And that is the symbol in a circuit diagram for a voltage source. So it could be a battery or an outlet, but that's the symbol for a voltage source. So right now, as we are looking at this, the switch is open, the current is not flowing, and there is no magnetic field. How do we know that? Well, we have some paper clips over here, which we talked about, right, at that last lesson. The idea is paper clips are temporarily magnetic. So they only become magnetic in the presence of a magnet. Right now, this solenoid has no current, no magnetic field. If I press play, the switch is going to close. Whoa, look what just happened. Switch closed. It generated a magnetic field that attracted those paper clips, okay? So we can kind of go through this introductory video, and definitely after I'm done, hop on the sim and play it, pause it, discuss it with your family members. And the idea here is we are using an electromagnet to do something for us, right? To make sound and allow us to work a doorbell. So here's how it works. When you press the doorbell, you're completing the electric circuit. So you can see here, the guest pressed the doorbell and that closed the switch, allowed current to flow, producing a magnet, right? And that magnet attracts the metal bar to hit the bell. Ding dong, right? That's how a doorbell works. Okay, so if we want to explore this further, I'm going to toggle to the Sim sandbox. And this sandbox is fun. There's lots of sliders. There's our graph. Graphs are our friends. Graphs are our friends. This graph is so cool because it lets us actually measure the strength of the magnetic field in the coil, okay, right here on the y-axis. So let's talk about a few sliders, and then I'm gonna let you go and play on your own. We have a slider, there's our fun word, solenoid core. So that's actually gonna let us adjust the magnetic material that's in the center of our loop of wire or our solenoid. So you can play around with that and see how it affects the strength of the magnetic field. Then you can actually adjust the number of loops. Like I said, this is allowing you to be able to explore electromagnets safely. So we can, I think, adjust between like 50, let's see if I'm right, 50. I think you can bump it all the way to like 500 loops. And we can see how that affects the strength of the magnetic field. Then you can also adjust the current, right? Or the amount of charges flowing through the wire, and the spring stiffness. Now, when you press play, you're going to hear the doorbell sound, okay? And for all of those parents at home watching, if you want to know how to turn the sound off, it's at the bottom right-hand corner here. I can turn the sound off. So that's for you. My recommendation for how to engage in the sim today is to try out those 3 slider based questions. I think they're really good. They kind of guide you with how to adjust the sliders, and they give you immediate feedback. So when you try it, you can adjust the sliders a certain way and press submit, and it will tell you if you got it right or wrong. I think they're great questions, and it's not just because I wrote them. And lastly, we've carved out other learning pathways for you to go down. I'm going to click on this real world example with the big question: is light magnetic? I love this question. I love this question. This is a great question. So let's investigate light next time we meet on Friday. And I'm going to describe light as an electromagnetic wave, because that's what it is, an electromagnetic wave. How cool is that? And we, of course, will discuss how we perceive light, and that involves rainbows. So that will be a really fun discussion. And until then, I'm sending you good vibes. Let's do a virtual elbow bump. You did a great job today. Thanks for joining, sending you rainbow emojis, and have fun with the doorbell sim. Thank you so much.